All right, today is day 3 of finding area of the shaded region. We've done this quite a bit now. We're going to continue to get better at it. Find the area of the shaded region. So as we look at this graph, show me with your arm, do you want to draw vertical lines or horizontal lines to find this area? Tell your neighbor, why would you rather draw horizontal lines? When we look at this thing, it's not exactly obvious here as you look at it, because one of them is an x equals equation, one of them is a y equals equation. So you really could go either way pretty easily. We agreed that we were going horizontal here, and the reason you want to go horizontal lines more than anything else is you're going right to left, and you're going to touch the same line each time. If you go vertical, at some point you're going to go red to red, and that's pretty awkward and not ideal by any stretch. So we're setting up this integral. Since I'm drawing horizontal lines, it is perpendicular to the y-axis. They're going to cross the y-axis when you draw them. So that makes this a dy problem. That means all of my problem needs to be in terms of y. So make sure that you've set this up so that everything's in terms of y. Show them with your fingers. What's your lower bound going to be? My lower bound is -2 because that's where I start. That's my y value down here at bottom. Show me with your fingers. What's your upper bound going to be? Your upper bound is going to be a +2 because I'm integrating all the way up to there. Then the thing I need to do is decide which line goes first, which line goes second. Which one is going to go first, the red or the blue? The red, because we go from right to left, right to left, right to left. And so it's going to be -1/4 y squared plus 1 minus right minus left. So in parentheses, the left one. Good. We can't just plug this in. If you do this, that's bad because now we have a clash of letters. We've got y values, we've got a y, dy, and then all of a sudden we threw an x in it. You can't do that. And so before we plug it in, we need to take this equation right here and we need to get it in terms of y, which means I got to get x by itself. So to do that, I'm going to add 2. I'm going to divide by -2. And so just to make it easier for me, that is -1/2 y minus 1. That is what I'm plugging inside the parentheses. That equation now in terms of y. -1/2 y minus 1. Issues with how we set that up. On this question, I would guess it's probably you're getting 1 point at least for setting that up. Okay, 1 point at least for setting it up. Now we need to integrate. Okay, and before I even integrate this thing, I do want to clean it up. You can integrate it all messy like this, but it's not good. It's going to get a little bit too weird for us. So I'm going to put it in order. Here's my y squared. Then I'm going to write plus, because it's minus a negative, 1/2 y. And then I've got 1 minus a -1, so it's really going to be plus 2 dy. That's what I'm integrating from -2 to 2. No calculus there. That's algebra 1. I combine like terms. Okay, once I've done that, now I'm going to integrate. And if you missed anything on our last test, we did really well on the separate integrate problem last test. The only place we made a mistake was at this point. Yes, sir? Yep. So if we missed anything, it was when we integrated. You add 1 to the exponent, so it's y cubed. What is my new leading coefficient going to be? 1/12, because I'm dividing by 3. So 3 and 4 together gets me 1/12. Same thing here. We add 1 to my exponent, y squared. Now it's going to be 1/4. That was the only mistake we really made last test. 2. Add 1 to my exponents, y to the first, divide by 2. We're taking that thing. We're evaluating it. Starting at -2 and going to 2. So all that means is I got to plug that in. So it's -1/12. 2 cubed plus 1/4. 2 squared plus 2 times 2 minus parentheses. You got to throw it all in parentheses. -1/12. -2 cubed plus 1/4. -2 squared plus 2 times -2. If this is a free response question on the AP exam, you run away from this problem. Do not try to simplify that because you are going to make a mistake. Okay, I would say about 60% of you would make a mistake in simplifying this, if not higher. It's hard. There's a lot of numbers, a lot of places to make mistakes. I would make mistakes. All right, so if it were a free response, leave it and go. Okay, Let's say we're multiple choice. I'm going to do it really quickly. 8 over 12, that's negative 2/3. 2 squared, that's going to be plus 1. That's going to be plus 4. That's going to be minus, that's going to be 2/3. That's going to be 4 minus 1. And that's going to be plus 4. If I combine all those things together, 4 plus 1 is 5. That's 9. That's 8. 8 minus 4/3 is going to get me 20 over 3, which is 6 2/3. Run away if you're not sure, okay? But if you have to simplify it, make sure you can. Questions on that? Today, we are going to do some rapid fire whiteboard questions. We're going to just do a bunch of them pretty quickly. I'm going to throw a problem on the board. All I need you to do on your board is show me setup, okay? So, for example, this one right here, all I want you to do is write that integral with the bounds, with the dy, the dx, hold it up. Okay, we're going to go through these pretty quickly. First one, go. When we look at this one, and you guys set it up correctly, you didn't really have any mistakes. We want to draw vertical lines. So if we want to draw vertical lines, that's going to be a dx problem because I'm going to intersect the x-axis. We go from my smallest x value, which is negative pi, to my biggest x value, which is 0. And we're doing top minus bottom. Okay, some of you wrote out the equation, which is good. But if it's just asking you to set it up, write f of x minus g of x. We know this is f of x because it's the line, and that's g of x because it's sine curve. But a lot of times, if you don't, you'll screw up parentheses. And so if you can avoid writing them down, avoid it. It'll just make you correct more often. All right, good on the first one. Let's try another one. That's crazy. Try it. As we look at this thing, okay, what I want to draw top to bottom here. No, you would have to break it up into multiple different things. It's not something we want to do. It would not be easy. You'd have to take square roots and do a positive, negative. Don't want to do it. Instead, we want to go this way. We want to go right to left, right to left, right to left. If I'm going right to left, that means I'm intersecting the y-axis. That makes this a dy problem. Okay, so it's dy. So then I need my bounds to be in terms of y. That was a big mistake we just made. My lower bound is -1. My upper bound is +1. I'm going right to left. Which equation is on the right? The purple one. I color-coded it for you, but you don't have to necessarily be color-coded. It's a negative parabola. So a negative parabola is going to open left. A positive parabola would open to the right. So we would go f minus g here. Questions on that one? Let's try another. Do it. How can we tell which equation is the blue one and the red one? Who thinks, what do we think on this one? Is this guy right here, is that the blue one or the red one? That is the blue one. The way we can tell that is x cubed. It's an exponential, and at the end, it's going up forever. The red one is 1/3. That means it's a cube root graph. That's that guy. Okay, keep working. How many different integrals am I going to need here? 2, because as I draw my lines, guys, as I go top to bottom, I'm going that direction right there. So as I integrate, this first one is going to go blue to red during that time period. I'm drawing perpendicular to the x-axis. So that's dx. I'm starting at my lower x value, which is -1, to my upper x value, which is 0. We're doing blue line, which is f of x minus g of x, top minus bottom. Then we take that integral. We got to add. Make sure you include that dx to separate them. I didn't see that mistake anywhere, but make sure you didn't forget that. Okay, my second integral, I'm integrating from 0. We're doing this. So I'm going from 0 until 1. It is dx again, but this time the red line's on top, so it's g of x minus f of x. Questions there? Yes, ma'am. You could, but if you did horizontal, you would have to solve both of these equations for y. And so you would have to have rewritten all of those equations in terms of y, which is not necessarily something I want to do. You can. It's not really that tough, but based on the equation that was given, it made more sense to do it the other way. Questions there? Let's do that one. Again, this is supposed to be rapid fire. It's not supposed to take us real long. Make sure we can set it up correctly. What would be better, going vertically or horizontally? Horizontal, and we can also tell that because these are gy problems, f of y problems. We want to do it in terms of dy. They're in terms of y right now. And so I'm going lower bound -1 to upper bound 1. I'm going right to left. So that means I'm taking f of y minus g of y. Good there. Let's do a couple more. We're doing well. Let's try that one. Here we go. As we set this thing up, we don't want to draw horizontal lines, especially because all of these equations are in terms of x. So if all the equations are in terms of x, you want to keep it in terms of x, which means we're going to draw lines perpendicular to the x-axis. From here, and tell me when I stop using the same line on top and bottom. Boom, right there. Because I switch, I go from blue to red, blue to red, blue to red. That's one integral. Okay, it's a dx problem. From blue to red, I'm going from x value of 0 to an x value of 2. And that whole time, I've got the blue line, which is just the number 2, minus the red line, which is g of x. That's going to tell me that area that I've drawn in so far. But I want to find the whole area. And so I've got to take that answer, and I've got to add to that this from blue to purple, blue to purple, blue to purple. That integral goes from 2 to 3. It's dx. And we're going to go upper bound or upper equation, which would be 2 minus the lower line, which is f. Questions there? Yes, sir.
Couldn't you subtract like from 6?
So did you go 0 to? Oh, you took 6. You can do some different things with that. I wouldn't suggest it based on what we're going to do in the future. Okay, so you could have done some different things that we could have done there. I think that's the best way to do it, especially based on what we're going to do in the future. But yes, you are correct. You could set that up in a little bit different way. All right, one more. Let's do that one. Again, if you feel really good, and I feel like a lot of you are feeling really good about what you're doing, that's great, okay? Because we got to get to that point. There's a reason why, again, we spent that third day doing it to make sure we're an expert at this. So we're integrating. We're starting at 0. We're integrating until 2 because that whole time we're going red to purple. We're going red line, which is g, minus the purple line, which is f, dx, plus the integral. Now we're going to go from 2 until 4. We're going red line, which is g, minus the blue line, which is h, dx. There's my setup. Questions there? All right, look at that paper I just gave you. So this second paper that I gave you here is free response questions on past year's AP exams. Okay, this one in particular, I think this is from like the 18 or 19 exam. It's pretty recent. It's kind of a mean one to not be calculator, but it's something that they expect you to know, so we want to make sure we can do it. Okay, we're going to give you about 4 minutes here. See if you can solve part A. Find the area of R without using your calculator. If you need to talk with your neighbor, great, but try and solve that in the next 4 minutes or so. Go. You might not have been able to finish this whole thing, but let's see if we can get the setup correctly. I think the integration part is hard, but at least be able to do the setup. So we're integrating. Anytime we find an area, we integrate. Which way would make more sense, going horizontal or vertical? Vertical. And again, it's pretty easy to tell that because these are x equations. If they give you x equations, there's like a 99% chance that you want to use dx problem here, and it is. Okay, it's a dx problem. It is much better to go vertical the whole time. How many integrals do I need here? Just one. Okay, we're going to integrate this thing starting at 0 and going until 2, because that's the ending x value, 0 to 2. We're doing top minus bottom, so we had to decide which one was top and which one was bottom. What do we think here? G of x. Do we think that's the top equation or the bottom equation? It is the bottom equation, and that's something they expect you to be able to do without a calculator. You got to be able to see that. This obviously is a parabola because it's squared. It's a downward parabola because it's negative, so it's got to be that one, where the other one is kind of doing that cosine curve there. So that one's a little bit tougher because they didn't really show you a ton of the picture, but that's going to be h of x. So when we set this up, if we were just trying to steal points, we would go h minus g and get my points, okay, and they would be fast. We are trying to find the whole answer, so I'm going to go ahead and write it out. 6 minus 2, x minus 1 squared. That's the top line, and we're going to do that minus the bottom line, so make sure you throw it in parentheses. Negative 2 plus 3 cosine pi over 2x dx. There's my setup. I'm probably going to get, depending on the problem, 1 to 2 points just by writing that down. Okay, again, a good free response question, you're getting 3, and we got 2 by not doing a whole lot more. So if you struggle with the next part, continue to get better at it, but it's not the end of the world. All right, before I try to integrate, I'm going to simplify a little bit. Not that there's a ton to do, but I'm going to distribute that negative. I get negative 2 x minus 1 squared. I get this guy right here, which is a minus 3 cosine pi over 2x. What is my constant that's going to be added here? 8, because it's 6 minus a negative 2, so it's plus 8 dx. With me to there? Now we actually need to integrate, which is the hard part here. If I integrate this guy right here, we can use mental u sub for that, okay? Because it's just x minus 1. What's the derivative of x minus 1? 1. It's a constant. So since the derivative is just a constant, we can do mental u sub, the opposite of chain rule, okay? So we are going to add 1 to my exponents and then divide by my new exponents. I would also need to divide by the derivative of what's inside. The good news for us, the derivative of what's inside is 1. Makes sense on that first antiderivative. Then we get this next portion. Negative 3 cosine pi over 2x. Again, this would have been my u. The inside here, that would have been my u. Since the derivative of that is just a constant, I can do mental u sub. So what that means is the antiderivative here. I got that negative 3. I'll mess with that in a second. What's the antiderivative of cosine? What comes before cosine? Sine. We could rewrite the baby, and then I need to divide by the derivative of the baby. So what do I need to do? Divide by pi over 2, which is like multiplying by 2 over pi. So it's like I'm taking this guy right here and multiplying it by 2 over pi. That is why I'm going to get negative 6 over pi. And then 8 is obviously going to become 8x. Everybody with me to there? That would score you another point if you got to that. Then we're evaluating. And we're evaluating from 0 to 2. So this is the world's worst problem here to set this thing up. But negative 2/3. And I'm just plugging in. 2 minus 1 cubed minus 6 over pi. Sine pi over 2 times 2 plus 8 times 2 minus, oh my goodness, there's just so much. Negative 2/3. 0 minus 1 cubed minus 6 over pi. Sine of 0 plus 8 times 0. If you just write that out, and you would run away from that question. Do not try to simplify that if we could. Okay, if you wanted to simplify it, you would have gotten that right there. You would have gotten 44/3. But we don't want to simplify if it were just free response, and this question was a free response question. Anybody got a question on how we set it up and solved? The setup, not terrible. The integration step was the rough step. That was the place where we struggled a little bit more probably than anywhere else. Questions? Yes, sir?
If you don't like the 0 part for the setup, like, let's say you just want to
Well, the problem is this right here is not 0. Right? Negative 2/3, because that's negative 1 cubed, which would be negative 1 times negative 2/3. I agree with you. If it were just 0, don't write it down. But it's not going to get me 0. And then also be careful. Sine of 0 gets me 0, but cosine of 0 gets me 1. So not, again, something that you don't want to just cancel out. So I'm good with that, but be careful. Anything else? All right. Here's what I'd like you to do for Monday. You've got 3 more problems on this worksheet. The rest of them are all calculator. You don't need to do anything by hand. Okay, set them up, type them in, get an answer. I want you to do 2 out of those 3 for Monday. Okay, you got about 8-10 minutes right now. You probably should be able to finish in that time period. Work with your neighbor if you need to. Set them up, solve them, go.